Well, hello, hello, hello. My name is Ryan Torvik. I'm founder and CEO of Tulip Tree Technology. We are excited to be releasing our new version of our Emerson Community Edition. This one includes an Arduino Uno R3 model inside of it. Here's how it works. All right, so I've got my downloads here. So I got my tarball here. So I'm going to do tar, ZXBF, Emerson, CE, tar. And then I'm going to CD in there. And I'm going to say install. What that's going to do is that's going to put some files, some scripts over, install a couple Docker images, and then actually install that Arduino plugin. So all you need to run this is your Arduino IDE, this tar that you get from us, and then Docker. Once you've got Docker desktop installed, all that'll work right there. So got the plugin installed. Let's bring up the Arduino IDE. Now, included in our package there that you downloaded, we have a few different examples. So we'll have some, I'll go through that a little bit here. So I'll go through a couple of those. All right, so the first one we got is pretty standard, is a blink. We don't have a hardware visualizer hooked up to this yet. So what we can do is actually view the system and actually see the pin values changing on the system. So we will build this sketch, export compiled binary, which will go and do that. And then we've got Emerson, so I got Emerson, and then load sketch. I'll load that sketch up. That'll start up the Emerson server. Boop, boop, boop. And then we bring up our favorite web browser, localhost 10314, and connect to that. You see up here, there's an actual project already running. So then we click on this project here, and there it is. So what we've got are, this is very empty right now. So what we're going to do is we're going to select some devices to look at. Let's look at the disassembly here. We'll look at the registers on the processor here. You know, for a more in-depth description of some of this stuff, you can go look at previous releases of the Community Edition. We've got a TTY here. This is the actual, when you write something out to serial, that shows up in TTY0. Serial, that's our USART connection. And then there's a couple other boxes. Let's bring up the device box for this one. We'll do ports. We'll take a look at the ports there. So there are all the pin values. And we'll just gonna put this over here so we can see it still. So here are all the different pins and that we've got, and they're organized in a certain way. And what we can do is we can just run this to see how it goes. So we're going, and we pause. Let's get it started. So we've got it running from the bootloader, so there's a whole bunch of other code that happens before your code gets executed. So just keep that in mind when you're running through this. So we've got, these are the port values. These are all the different values we've got for the ports. If we look here and we step, I don't know, 40 instructions or so, you'll see that the value of port B has changed. So looking at a schematic of the Arduino, we'll see that the LED, let's see over here, this LED built in is number 13. So looking at our schematic, that's actually the fifth of the B's, of the B port. So you'll notice it's over here. So setting that to 1 is actually, this is the fifth bit of the B port. So every time we're stepping, you'll see, or every time we're going through, and it's going through and just setting that to high, low, high, low, high, low, high, low, high. And you see it down here, we've got an info message about when the stepping completes. It's an info, so I don't want to watch that. Don't just tell me about these warnings. These warnings here are to remind us and to remind you as a user that there's still a couple unimplemented registers that we are going to have to do. So you might find some erratic behavior if you're interacting with one of these registers. All right, so our next example is, so that's a pretty simple, and you can change the values in here. I can change this to 12. Let's do that real quick, actually. We'll change that to 12. So 12, which if we go back to my schematic, 12 is going to be the fourth bit of the B port. We go over here and say export compiled binary again, and then I'm going to go and actually reload the sketch. Reload is reloading the exact same sketch. It doesn't stop the server, it just reloads the sketch as is. And so you'll see, and if you look over here, you'll say, okay, it stopped a little bit, and then that is stopped. You go back to our window over here, you'll see that this instance has been shut down, but with reload, there it is. It just brings that back up. So we can go again, and then we can do the same thing we did before, except now you'll see that it's 1, 0, so the 4th bit is being set and unset. So this right here, that's the one we're looking at that's changing when we're going through. All right, so that's this one. That's this one. We've got another one. Let's see. We have an example where we have the overflow. So if we set up that we actually want to be triggered every time that the timer counter 1 overflows. This is how we set this up. So we have this prescaler. We enable the overflow interrupt, and then while the loop is happening, just whenever that timer counter 1 overflows, we'll actually get this triggered and we'll be able to print that out. So let's load up that one. And to do this one, so we'll export compiled binary, so that's done. So for this one, we're actually going to say load sketch instead of reload sketch like we did at the beginning. So this is actually going to shut the server down, load the new sketch into place, and then restart the server. So we'll say load sketch. And you can see that the Emerson terminal's been switched over to this window now. If we go back to our other one, you'll see it's not there anymore. So that's running. And we can go back to our window here, refresh this window, and the new sketch has been loaded into here. So what this one does, as you see, it'll run for a little while, and then every time that timer counter is 0, so let's look at timer counter, which one would we set? Timer counter 1. Timer counter 1 overflow set. So we're going to go and bring up that box. So in this situation, we're going to go here. We're going to say, okay, give me a device box for timer counter 1. And we're going to say, go. And then it's just going to print, boop, 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 boop. You can see here, so timer counter 1 is going, so the lows and the highs. So if we step again, you'll see that 24, 25, 26, a bunch of times you can see that. In fact, if I want to watch it happen, what I can do is I can edit this. I'm going to say FF. And then I'm going to say FE. There it goes. So that'll actually kick off that interrupt. So it's going to kick it off a little bit sooner now because it's right away. So you see how it's taking some time, but you can actually go and modify the values of those registers, and then they'll get set that way. And then they'll go sooner. So you can kind of play with this and play around with that at that level as well. But that's that serial, so that's going over the serial port and going in this way. All right, and then the last example that we have is a little bit more complicated. This is a debouncing algorithm. So I'm sure most of you are aware that, you know, when a physical button gets pressed, sometimes the physics of it is like, oh, it doesn't always press all the way down or whatever. So the debouncing is kind of to smooth out that transition between pressed and not pressed. And so we got a debouncing algorithm, and what we're going to have is we're going to have a bunch of test data, which is like, okay, not hit, it's hit, oh, and we're going to test that our debouncing algorithm actually smooths that out. And the way we're testing that is every time we're running through a test, we're going to say, yes, this is the test number that we've got, and then the actual, when does it get pressed and when does it not, and when does it get released? And so you can actually see like, okay, it gets pressed, gets not pressed, gets pressed, released, and how often it's going to be. So we expect the first one is like, okay, that's going to be pressed and then released once. This one should be pressed and then released and then pressed and then released, and so on and so forth. So let's build this, export compiled binary, and then we will load sketch, go back to our window. There's our active session. And then we're just going to play and let it go. So test 0, and then it's pressed, and released. And then test 1, it's going to go pressed, released, pressed, released. Look at that. So our debalancing algorithm looks like it's working. All right, so we're really excited about this. This is a new foray. We've got our first model out there, general purpose model out there for you guys to play with and use. So we're really interested in see, hey, what do you guys think? How does that work? Does that, what kind of examples are you looking for? Some things we're looking for the future. We've got a hardware visualizer that's similar to a lot of the ones that you see out there about, actually interacting with this. And then we've got better test cases. We've got interaction with GDB, so you'll actually be able to connect it. You can connect it with GDB right now if you have a build for it, but you were doing instruction level debugging, so we're going to look at like, okay, how can we do better than just instruction level debugging through GDB? And we've got, what else do we have going on? Oh, support so that we can get stuff input. You'll see that the debouncing test, we did that inline inside the code. We're going to be getting data in from outside the system so that we'll have some, and we'll demonstrate that too. It's like, okay, here's how you actually put data into the system, verify your algorithm, and then run your algorithm, and then verify that this stuff actually got through on the other side. So very excited about this stuff. If you like what we're doing, or you're interested in the kind of stuff that Tulip Tree Tech's working on, join our Slack channel. We'd love to get feedback from you guys. And we're building models of the Arduino right now. We're building a bunch of other proprietary models. But if there's something that you really would love to see us do, we've been building a model for you. So thanks for watching. We'll see you guys soon.